Now we have Ariel Chang, a new task-oriented approach to better preserve local extreme values.
Hello, everyone. I would like to end the sections maybe in 15 minutes time and then do a quick 3 minutes demo and then so everyone can happily ending happy FOSS4G events last day afternoon sessions. I'm working as a researcher in the Harvard City University together with Inga, and our lab is focused mainly on geovisualization, cartography algorithm development, as you may see from her and my project presentation today. So what is project ARCOR? ARCOR stands for Task-Oriented Data Classification and Design of Core Field Maps. Core field maps, as many of you may know, it is a colorful map especially used for polygon layers. So we are dedicated into programming to better display of the local extreme values within the spatial extent. And perhaps we will also develop a data classification method, especially for hot and cold spot analysis. Not but not least, also we will include spatial clusters, large differences of neighboring polygons. So we, as a ARCOR project that lasts for 3 years, we will combine development and also publish some papers about these 4 work packages, and also compare this new method to the traditional classification method. We already published our QGIS plugin into the official repository. It has QGIS version 2 and also QGIS version 3. So according to your computer environment, no matter it's Windows or Linux-based, you could always use our method in your computer calculations. We also include a GitHub website, so if you find any issue regarding to this plugin or any method suggestion, please don't hesitate to come and also publish something about your comments. It will always be welcome. So the goal of ARCOR is, we wanted to, just like I said before, so I think I will skip this slide very fast. But as many of you may know, there are several different classification methods that already be implemented from others, and some of them are only provided, for example, pretty breaks only in QGIS. Geometrical intervals, for example, only provided in ArcMap, and in many cases, during my data testing, I realized that the breaks generated from the same data set with the same number of classes, with the same method, for example, Yanks, it will have different breaks as output between QGIS and between ArcMap. It is not really something that we can discuss further onto these sessions because it's definitely developed by some different persons and possibly not really people looking into this. So. But anyway, this research will be focused on how this task-oriented classification method works. So here is real data examples. This is a polygon data set within the city Berlin. Contains how is the city distribution of percentage of workers living in this district. For example, from this map, you can see the red area, has more people between 25 years old to 40 years old. Okay, maybe I choose 45 as a threshold. So more than 65% of the people are living in Berlin, in the central area, in order to commute to their workplaces, office, and so on. And from the right-hand side, the equal intervals, you could see that from the map, they are the same data set with the same number of classes. But you could see if a non-GIS user seeing this map, they possibly will think, okay, Berlin seems to be quite happy places to live. If you use the right-hand side map, it shows less people actually working in Berlin. So it's that kind of data bias. This is also a more zoom-in example about in the middle polygon, which colored by the red boundary, is local extreme values, that it has larger value compared to the neighbors. In these cases, Yang's optimal classification method did not really very well preserve it because it has the same data class, which is on the 5th. I think, imagine if you reclassify them from 1 to 5, then it will have the same class number as one of its neighbor, which has an original value of 0.27. So how is this method works? First, we use in open source software, of course, in Anaconda packages. They contain Fiona, Shape, R-tree, spatial indexes in order to accelerate the whole neighbor search process. So the data will be looped through each polygon to find the center value and also how the value compared to its neighbors. So if there are over 1,000 of polygon considered in the database, then there will be 1,000 value be looped through, 1,000 records, sorry. And following by the last step, not only just the center value it will be preserved, but also one of its closest neighbor value will be recorded into the database. So we're back to the last slide for this example. Number of 1769, it is definitely an important value because it is a local maximum. And among all the neighbors, it has an orange polygon, which has a value of 7.552. It is very important, and it will only be preserved in the algorithm because it has the closest value compared to the others. So with these two values, we can plot it into segment into the matplotlib in Python libraries. And we could, in this method, we could plot all of the local extremes. For example, if there are 200 local extreme values, then here you will plot 200 segments. And then next step, we program a plan swap algorithm, swap from the minimum value of globally minimum to the globally maximum. So you can imagine there's a vertical line sweep from the left to the very right. And it will stop at exactly this break, 3,600, because it has the maximum of intersection happened. So we retrieve the first break. After that, all these intersections which intersect this swap line will be removed from the database. And the second sweep will be executed again, so that here is the second break happened. So theoretically, if there are hundreds of segments plotted here, the extreme cases is they don't have any overlap. Then there will be hundreds of class breaks generated. But in the normal cases, it should be less than 100. So this step will be iterated until there's no segment left in the database. So here is the whole implemented diagram. First, there will be a multi-part to single-part script to be executed on the original data set in order to get one-to-one relationship in terms of center and neighbors. And then this neighbor search were done by Fiona to find where is the local extreme value is. And here, they generate two tables, which contains of where are the ID of local extreme values and also how is the relationship pair between them. And then this data will be going to SQLite database and then be merged into only one table, which called localextreme.sql. Here is already in database, so please ignore CSV. And then there will be matplotlib to plot all the segments as the diagram we see previously. So as I mentioned, I would like to do some demo here between the sections. But you could see the plugin in the official repository. Until today, the plugin has been uploaded about 1 month time. There are 274 users already downloaded. And here is our GitHub lab website. So it shows a very clear instruction how to install the plugin and also how to install those Python packages in order to run our plugin. So here is how the QGIS plugin looks like. You could load any polygon vector data set, and then you could display the color as you wish. And then you could find our plugin into the vector menu, and then you could open the windows like this. Here we have several different functionality. I will illustrate it accordingly. I would like to show in QGIS. So if you already installed the plugin, you could just click on the icon, and then here there will be a drop-down menu that shows all the polygon layers here. In this case, only one. And then here are all the all the fields that has the digits or numeric values here that will only be shown. If the field is a text field, then it will be skipped. And here is the minimum value difference to be preserved, which means how is the step of the sweep line to jump. So you can imagine if the value here is smaller, then the algorithm, of course, will take longer to execute. So maybe the suggestion minimized value is 0.2, so please don't give a value lower than that. In order to demo, I will give a larger value. And then you could give any desired class of number you want it to be shown in your output. In this case, I will just leave it as a 10. And here is the color ramp. Now we only provide 3 options, but you could choose one, run the result, and then adjust it afterwards to the color ramp that is provided in QGIS. So I will possibly choose this one. And we have 3 classification methods. One is local max, that you show all the differences around the local maximum polygon. So if you choose local min, then there will be more color diversity among the local minimum regions. In this case, I will show the default of the local extreme, so I'll let it run. Okay, so there will be a pop-up, and then the script is running. So we will come back at later. We will continue our slide. The algorithm itself takes maximum 10 seconds approximately to execute. So here is the result of the deprived index of Hamburg. This map shows where is the region in Hamburg city are needed to look into the most, which means they may contain many job loss or people applying for social help or any other. There are 6 different social indexes into a summation, but the data itself also be nominalized so that you could see the red region, there are basically higher unemployment rate and also higher social help applicants. Compare our method with other classification methods, you could see that Accord, they show more diversity among the whole city of Hamburg region. If we zoom in, you can see that at the Accord method, local extreme value, maximum value 4.14, it is well preserved. But for example, Quantel, it is somehow merged with one of its neighbors. They are basically used with the same color scheme and also same number of classes. So, and I could show you the numeric statistic evaluations. You could see that from Accord, the red line, no matter what number of classes it was given, it has the best preserve rate among the local extreme values. So the equal interval, basically, it doesn't really increase a lot, even though you give a lot of number of classes. And they will never reach to 100% preserve rate, but our method is possible. So how the preserve rate be calculated? It was reclassed by the original value, and then you dissolve with its a new value of the reclass number, of course, in this case, and then you overlay them with select by locations. So if it is selected, then it is preserved. If not, then it is not well preserved. And another example is how the election last year happened in Hamburg. SPD is a left-wing party, and it stands for social help for the laborers. As you can see, the diversity among Hamburg region was also quite a lot. There are higher SPD supporters at the east region, and also some north, and also some south of the River Elbe. But in general, our statistics shows if the data of the number record is smaller, for example, there are simple data set, then the alcohol reach higher performance when the classes number are smaller, which means it's a better performance method, even though given a relatively smaller number of classes. So here is another example of a Germany rainfall. Then you can see that where are the data value distributed among different classification methods. And here is the evaluation curve of that rainfall data set. And here is the summation of the table among different tested data, and also with the ACRO method. As you can see here, with a smaller number of the data count, for example, the Berlin work age population ratio 190 as a total number of class data, and then you could have 50%. That means with a smaller number of the total classes, you could preserve 100% of the location values. So here are a short summary about what we are going to do in ACRO project in the near future. Yeah, you could just have a look. And I would also like to highlight that there is a workshop tomorrow morning that I will show how to program QGIS plugin with a very fundamental instruction. So if you are very good already at QGIS plugin development, please don't come. Also, I will tell you what is the differences between QGIS version 2 and 3 in terms of plugin development. So we can now possibly go back to the QGIS, so see what's going on. Okay, so when the classification finish, it will pop up dialog, tell you, okay, it's finished, then you could close it. So this is the original that I overlapped before, and now is the ACRO method. You could see that the color and also the classes were distributed accordingly. Then the user can just choose in the properties. Within another window. And then you could choose from here with the color scheme. For example, if I want to compare, then I should choose somehow similar. Yeah, I can see here. Okay. So maybe it's not really exactly the same, but yeah, you could see from here like how the two different methods compared with the same data set. Okay, so that's my presentation. If you have any question, please don't hesitate to ask.
Any questions? We are very sleepy.
Sleepy session.
Or maybe we just don't know how to design maps, as I do, so I don't know what to ask you.
Yeah, this method is more for data statistics researchers.